you will get the screen like this, and it will directly enter to this mode. So it is starting with Ubuntu by default. Let us just wait. Yeah, you have got this Leica GNU radio. So now go to this application. So here programming, you have this GRC. So you got this. Usually this will open whichever is already opened. So in the last class we have done this. So today I am going to open a new file. So you can open new. Here you will have 4 options, right? You will have a Qt GUI, WX GUI, NU GUI, like this. Here you need to choose Qt GUI. Okay, so this is our new thing. So now how I am going to take the block. So initially we are given with the manual. So look into the manual and search here. So in view you will get the show block tree panel. So you can click it on. Sometimes what happens is that if this is not checked, here you will not get the board here. Sometimes you might have extended this, okay, towards the font. Then also you may not be finding the search tree. You have to check here, do you have a point here, so which you can pull on to get the tree. So now you got this tree. So it is from here we are going to take different values. Okay, so now for the information, here we have different things. If you see here, so first, what are these points? So the first one is options, then you have random source, then GUI widget. So you have to create each of this block. So now I have to, for example, create this random source block. So first let me create this. So I will put a search bar here. So I got random source generator. So now I will keep this over here. See what is it? I will double click on it. I will get these values. So this ID is random source. Again type what I want. As such I want to have it as a byte. So I make it that N0. Let me check how much do I want. Say for example I want it to be 256, and I am going to use say some 32,000 samples. So either I can use 32,000 here, or I can write it as, so this is a variable. So let me now write it here. Click here as apply. Okay, right? So now here I will come. So this is a variable whose ID is sample rate. Okay, so now let me just copy it. Okay, and I'll come back here and write it as sample rate. Apply. Okay, so now see, you can say that it becomes 32K. So why I have to make it? See, I can do vary it in 2 ways. I can straight away put here as 32,000 also. Okay, so why I am using this is the sample rate will be the one in along with which you will be using it from transmitter to receiver. So I keep it like this. So now I have given you one information. How to create this random source block. So now let us see into this. I'm not going to give this like this. You have to create each of the block and you have to work with it. Now coming into this, you have say for example this constellation modulator. So when I come here, I have to once again search for constellation modulator. So here you go and type const. Okay, so I am getting here, see I am getting here as this constellation modulator. So I carry it on over here. So I got it now, right? I have to now give the values here. I have to write the constellation, what it is, okay, which I don't know. So for this, how I can give it? You already have a block to say that. So what you are getting this constellation modulator is by means of this object constellation rect object. So come here, you have constellation rect object, so that you put here. So in this you have the mapping. You are saying how many bits. Suppose you want to have more than 4 bits. If it is not QPSK, you want to make it 8, then you should given it as a 0 to 7 or 8, and how the points should be placed. So this is like your custom mapping. Okay, so now I have given this straight away. I keep it like this. So here whatever I have given, so this ID I have to take it. Now you got this. Oh, let me add it. Now when I add, how to connect the blocks. Okay, so this is my input block. So I mean input, it should start from here. So click and then click another one over here. Okay, if you do it in a reverse way, the arrow mark will become reverse. So there are two things that you need to do. Now that I have created the baseband modulation is over. So one thing is that I just want to see how this constellation looks like. So then I will go here and pull this one over here. Alright, so this is constellation scene. Add it up with this. Okay, now this is over. Now let me just run it. To run, you have to press this triangle over. So press it. So it asks me to save. So let me just save it as PR1. Okay. And I save this. See, you can see that you are able to get different. So this is how your block it has obtained. Okay, so you are going it around 32K. So now you will have a problem. See, in case of MATLAB and all, when we give it, you will get like so you won't get this much of distortion, but here you are getting it. Okay, I'll tell you why you are getting this a little later. So this moment, let us close this and come back here. This is how it works. Now I have to find out the sync, that is whatever is created here. Now I will be explaining these constellations. So what are all over here and what is that I am getting it. So let us look into this course. So okay, because see, you are working with the number of samples. You can put it as 10K or 32K, how much ever you want to that, and that will become from num samples. You have to get it. So which will be again another variable. Okay, so here are the variables. You have the sample rate over here, which gives you around 10, 100, 1000, 1000, almost 1 mega samples, and from there you are giving here as 10k. Okay, so you can look into it and you can vary it however you want. So now let us see whether this model works. You will have an error. Okay. Okay, see, this is one model wherein I have not used it. See, you can actually enable or disable. Okay, I have disabled it, so it is showing me to enable it. Right now I don't want that as such. Okay, I am using the equalizer, and okay, I want to use this constellation eye diagram. Fine, I have this. Suppose I use a channel model, it means that I am trying to use it like a block, a simulated channel. Okay, let me tell it from here. So what you had is random source, then you have the constellation. So here you have this multiply constant. So this is given to adjust the gain in the hardware. Next comes your USRP sync. USRP sync is nothing but your hardware over here. Okay, so this is the USRP. So when you say USRP sync, the data from here goes to the board. So what we have here is, so you don't have an option, or it's enough to use the same thing. So the sample rate you have to maintain it, and you have here the RF option. So here you have to give to which transmitter you have connected it. So there are two options, transmitter 1, transmitter or receiver. Since we have connected it to transmitter 1, we are writing it like this. Okay, so this is your USRP sync. Okay, now you have created the you have created the modulation, and that you have dumped to the receiver, in the sense you have put it to the board. Now it should get transmitted from the transmitting antenna, what we have kept there. Okay, from transmitting antenna to the receiving antenna. So you have it over here. So this is your transmitting antenna, and here is your receiving antenna. So once you receive it, again it has to be fed back to the computer, right? So that is done by this USRP source. So once you do this, you will have this input is going to two things. One is QTGUI time sync. So it means QT time sync is there. So it shows that like you can see the plot. What is that you have received? Then you are synchronizing it using this polyphase clock synchronizer. Then you are giving it to the equalizer. So meanwhile, again after equalization, you will give it to the post-toss loop, and your equalized output you want to see. So you have this constellation sync, and you have to adjust the frequency also. Frequency synchronization is done by this post-toss loop, and its output is also shown through a constellation graph. Then you have this null sync is like simply to, like, you can give different types of sync, so you are giving it. So there is no much information on it. So if you want, you can put this eye diagram, and there is a little mistake over here, so I will be disabling this and this. Okay, so if you are not disabling it, it will throw an error. So like without connecting it, if you keep, So now with this, let me once again run and check what happens. So you have got 3 output. So this first one output is like after equalization. This output is after providing phase lock loop, and this one is actually the signal that you are receiving. Okay, so this is your QPSK, a signal that you are receiving it from the receiving antenna. Now what and all you have to work on it. As such, you have to take the, even if you have to take a pic, you will have this you have a tool wherein you will have you will have a reports panel. You can put it as a save reports in a desktop. Okay, and you will have you will have screen capture. Okay, so this also I am using it in desktop to save. Okay, I am using screen saver. Now let us see how this goes. I will be now running this. So once again I will get these values. So now what are the changes you can make out? Okay, I am now going to vary the antennas. Now let me see that there is no interference at all, or see you have a straightforward antenna, transmitting and receiving antenna. So you can see that your a clean constellation diagram. So you have more number of lines because you are transmitting at 32,000 samples. Okay, and then you can see that there is a little revolution and little revolving around of your so if you see this here, see it is a little bit slanting, right? And the if you see the points, they are actually not revolving, in fact. So it looks somewhat similar to both, right? Now I am going to give a multi-path reception, means to say, now in between them I am keeping another receiver which I have not used, and I am keeping this receiver somewhere over here. Okay, your actual receiver is far apart with different diffraction and multiple paths arriving. So now let us see what happens to this. So you can see that because of multiple path, here the eye opening becomes less and their movement is also more. Now I am coming back and I am keeping this intruding receiver somewhere out. So now this is not required for me, and this one I am slowly moving it towards the receiving antenna. See, when there is a movement, so you can see that. So if you can see when there is a movement, you can see that the equalizer output is revolving, right, clockwise or anti-clockwise, the rotation, isn't it? So this is the velocity with which I move here. With that, proportional to that, your right pattern will move there in equalized output. Whereas if you see the second graph, you will not make that change at all. So there is no revolution, because using the coaster slab, you have loop, you have phase locked it. So your frequency variation is also not having much change. So this is how your equalizer is working. So now Let me close this. So what we have done is, we have now created two things. One is the qp constellation.txt. Let us open and see what it is. This is giving you the recordings, okay, in the sense like what are all the registers you used and all. Okay, this may not be useful for us. You have this one, this qp constellation.png. so this is like your whatever you have kept it over there. So now you can as well take up the pic of your code also, I mean your output also. So you can take the okay, sorry. So you should do the print screen only over here. So what you can do is you can keep it like this, wherein you are getting the entire screen, and then you give a print screen option. So that should be saved. Yeah, you have this name, so you just save it. Okay, so you will be getting it over here. So that is in the pictures you will have. So this must be the thing. Yes, you got it. Okay, so this is how you have to take the results, and you need to write the informations also, like inference regarding what happened when you give the when you vary the velocity, or when you vary the different multiple paths that you are providing it. So that's it for this experiment. So you can work on this.